Hello everyone, I'm Ming-Chi Han, and this is the explanation video for homework 2, question number 5. So in this question, we are given a situation that uh, the situation of analyzing a grocery store's customer flow, and is given as a Poisson process. So this part is already given. The Poisson process equation. Let's say the probability of number of customers arrive in this time range would be something is equal to this part. So with the equation already given, what we really need to do is to just plug in the numbers and figure out the questions. This is pretty intuitive. So part one would be to find lambda with this thing in here, and it's also said that that in 2 minutes at least one customer arrives is equal to 0.3. So plug in 2 as t. This t also will be the same t in over here, and at least one customer arrives will be k here, and that's all the variables that we need to figure out what the lambda is, because the other side of the equation is 0.3 is already given here. So yeah, so part one is pretty simple. So this 0 would mean that the probability of having absolutely no customer is equal to 0.7, because it said that at least one customer arrive is equal to 0.3. So no customer arrive is equal to 0.7. And here I have 1 minus 0.3 will be the same as this part. And do the calculation, we find lambda is equal to this value. And that's for part one. The second part would be to find the probability that in 3 minutes, no customer arrives. No customer arrives would mean that k is equal to 0. And in 3 minutes, this t is equal to 3, plug in the value. It's pretty straightforward, just do the plain calculation, with lambda is already calculated as this value. So this probability is easy to calculate, that's it. For part 3, it says to find the probability that in 10 minutes, at least 2 customers will arrive. So by at least 2 customers will arrive, it would mean that 2 customer counts and 3 customers arrive in the 10 minutes also counts, and also as 4 as 5 and all the way to infinite, which is a lot of calculation. I cannot just do that. But what I can do is that I can find the probability of having no customer arrive and having one customer arrive in the 10 minutes window. So what I did was, the probability of customer arrive in 10 minutes larger than or equal to 2 is the same thing as 1 minus the probability of customer arrive in the 10-minute window equal to 0 or 1. So it's just 1 minus the probability of customer arrive in 10-minute window equal to 0, and the probability of one customer arrive in a 10-minute window, and do the calculation over here, we get this value for this probability, and that's it. For part 4, the probability that in 1 minute exactly one customer will arrive. So this 1 would be this time range in 1 minute, 0 to 1, t equal to 1, and exactly one customer, k, would be also equal to 1. Plug in all the value, and the probability of the customer arrive in the 1 minute window equal to 1 would be this value. Plug in lambda, plug in everything that from here, I get a final value 0.149. That's That's the final answer. And that's it for this question. It's pretty much straightforward.